In this tutorial about the lines and angles, we are going to study about the transversal lines. But before we actually go there, we would like to study about these two axioms and a theorem that we want to prove. The fundamental knowledge about these three things will be very useful in proving theorems related to the transversal lines. All right. Now, first, axioms. Axioms are the statements or expressions or propositions that they have already been accepted universally. So, axiom 1 states that if there is a straight line POR and a ray comes out of this line, then the angle so formed by the combination of the ray and the straight line, angle A and angle B, the sum of those two adjacent angles is equal to 180 degree, meaning A plus B is equal to 180, right? Axiom 2 is actually a converse way of stating the axiom 1. They basically can be deducted from each other. It states that if the sum of two adjacent angle is 180 degree, which means A plus B is 180, then the non-common arms of these two angles, the non-common arms will be the arm PO and arm OR. That these two non-common arms will form a straight line. So, having known about these two axioms, we would like to collectively call these axioms as linear pair axioms. Okay, now let us take a look at this theorem that we really wanted to prove, and these axioms will be useful in that. It states that if two lines intersect each other, so line PQ and line MN, okay, they are intersecting at a vertex shown as vertex, let's say this is vertex O, okay. What it states that the vertically opposite angles in such arrangement are equal. Now, you are going to learn about this term called vertically opposite angles. So angle B and angle D, they are vertically opposite angles. So B and D is one pair, and then angle A and angle C, this is also another pair. So you can write it here, okay? So these two pairs are the vertically opposite angles. And we would like to prove that the angle B is equal to angle D and angle A is equal to angle C. Alright, so first let us begin with the line PQ. The line PQ has a vertex O from where a ray ON is coming out, correct? Now, what are two adjacent angles formed in this arrangement? They are angle A and angle D. And we can state that using axiom 1 that sum of these two adjacent angles will be equal to 180 degrees, simply because these two angles are on one side of a straight line, right? And likewise, you can state that if you were to take the line segment MN and then there is a ray OQ coming out of it, okay, in that arrangement, you will say that there are two adjacent angles, angle C and then there is angle D. They will also be equal to 180 degrees, simply because it is a combination of two adjacent angles, right? Simple enough so far, correct? You are with me. Now you see that A plus D is equal to 180 degree, which is equal to C plus D. Or in other words, if you were to simply cancel out D from both sides, you can make a simple deduction that angle A is equal to angle C. And isn't that what we wanted to prove here, right? And just like using the same logic, we can also prove that angle B is equal to angle D. That means the vertically opposite angles with the intersection of two lines are always equal. Okay, so now let us talk about the transversal lines. Take a look at this diagram in which we have a transversal line, and this is about an arrangement in which there is one line AB and this line segment intersects with two other lines, the line segment PQ and RS. In this case, we have made a situation that the line segment PQ is parallel to the line segment RS. But for a line to be a transversal line, these two lines, they don't have to be parallel to each other as long as there are two line segments being intersected with a third line. The third line that intersects both of these lines is called a transversal line. Okay. Now in this arrangement, we are seeing a lot of different angles being formed. Okay. So there is angle 1. We will go in a clockwise direction by naming all of them 2, 3, and 4. Then there is 5, 6, and angle 7, and then you have angle 8. Okay. And in this arrangement, we would also like to define few more terms such as corresponding angles, interior, and alternate interior angles. Corresponding angles, they will be defined as the pairs such as 1 and 5. Okay, that's one pair. Then you will say that 2 and 6, that is another pair of corresponding angles. You will say that 3 is corresponding with 7. Okay, and finally you will say that the last pair of corresponding angle in this arrangement will be 4 and 8. Okay, now let us talk about the interior angles. The angles that are inside the boundary of this structure, such as 3, 4, and 5 and 6, they will be called as interior angles. Now, when you have studied about the interior, you will say that what about angle 1 and angle 2 and 7 and 8? You will say that these are exterior angles, okay? 1 and 2, and then 7 and 8 are also exterior angles. So that's what we can state here, all right? And finally, we will state that the alternate interior angles will be pair of angles such as 3 and 5 or 4 and 6. They will be called alternate interior because one, they are all interior angles. Second is 4 is in a direction opposite to the angle 6, right? It is on the left hand side of this transversal line, but 6 is on the right hand side of this transversal line. Likewise, 3 will be an alternate interior to angle number 5. So this is about few more terms that you need to know about when we have this specific arrangement of a transversal line. Okay, this axiom states that if a transversal line intersects two parallel lines, this is a necessary condition that if these two line segments are parallel, PQ and RS, then each pair of corresponding angle is going to be equal. And that simply means that in this specific arrangement, I am stating PQ is parallel to RS, right? And that implies that angle 1 is equal to angle 5. Angle 2 is equal to angle 6. 3 is equal to 7 and angle 4 is equal to angle 8. And that is an established fact that we don't need to prove anything because it is considered as an axiom, okay? Now with this arrangement, we would like to prove a theorem. So this theorem states that if a transversal line intersects two parallel lines, then each pair of alternate interior angles is equal, okay? So what are my alternate interior angles in this arrangement, in this specific diagram? I will say that this is the case of my alternate interior angles, correct? At this moment, I would like to prove that 3 is equal to 5, okay? So let's take a look at this axiom. It states that since these two lines are parallel, that means angle 1 is equal to angle 5, right? Because they are corresponding angles. So I can state here that angle 1 is equal to angle 5 because of axiom that we have just stated here, right? But at the same time, if you only pay attention to the line segment AB and the PQ, what are two vertically opposite angles? I will say that angle 1 is equal to angle 3 because they are vertically opposite. So you can state very clearly that angle 1 is equal to angle 3 because they are vertically opposite, right? In that case, when you have a situation like this, you can state that angle 1 is equal to angle 3, right? We already have it, right? At the same time, you are saying that angle 1 is equal to angle 5. Or that simply means that angle 3 is equal to angle 5. At the same time, using the same logic, you can say very easily that angle 4 will be equal to angle 6. So this is our discussion on the transversal lines. We studied about the vertically opposite angles, the corresponding, the interior, and the alternate interior. At the same time, we also proved a theorem about equality of two alternate interior angles if the lines being intersected with the transversal lines are parallel.